satisfy this relation, we have to find out the value of two numbers. So let us again say that the two numbers are a and b. Harmonic mean would be 2ab by a plus b, arithmetic mean would be a plus b by 2, and geometric mean would be under root of ab. Now given to us is harmonic mean is equal to 4, therefore 2ab by a plus b would be equal to 4, or ab would be equal to 2 times a plus b. Let us say that this is equation number 1. So ab equal to 2 times a plus b is our first equation. Also given to us is 2a plus g square equal to 27. That is 2a would be equal to a plus b and g square would be equal to ab. Therefore a plus b plus ab is equal to 27. Also we know that ab is equal to 2 times a plus b. We substitute this value over here to get a plus b plus 2a plus 2b equal to 27. This becomes 3 times a plus b equal to 27, or a plus b equal to 9. Thus we get a plus b equal to 9. Therefore when we put a plus b equal to 9, we get the value of ab equal to 9 into 2, which is equal to 18. When we solve these two equations, we get either a is equal to 6 and b is equal to 3, or a equal to 3 and b equal to 6. Thus we have solved this problem. Now let's study the inequalities associated with AM, GM and HM. The inequality is AM is greater or equal to GM is greater or equal to HM. So out of these three means, AM is the maximum, GM comes next, and then comes HM, or HM is the least of these three means. Now AM minus GM would be equal to a plus b by 2 minus under root of ab. This becomes a plus b minus 2 times under root of ab whole divided by 2. Now a plus b minus 2 times under root of ab is nothing but equal to under root of a minus under root of b whole square divided by 2. Now under root of a minus under root of b whole square is a positive quantity. Therefore am minus gm is greater or equal to 0, or we can say that am is greater or equal to gm. Similarly, we can prove for gm greater or equal to hm, and thus we get the inequality as am greater or equal to gm, which is greater or equal to hm. And this is one of the most important inequalities that you will come across in mathematics. So let's try to solve a few examples based on this inequality. Consider the set of all rectangles with the fixed perimeter P. Show that among all such rectangles, the square whose side equals P by 4 has the maximum area. So in this problem, we have to consider the set of all rectangles with a fixed perimeter P, and we have to show that of all these rectangles, the square which has a side equal to P by 4 has the maximum area. So let's try to look at the solution of this. Let us say that this is a rectangle in which the length of the side is A and the length of the side is equal to B. Therefore, perimeter is equal to 2 times A plus B, and this is given to be equal to P. Area of this rectangle would be AB, and from this we get the value of B equal to P by 2 minus A. Therefore, the area would be equal to A into P by 2 minus A. Thus the area of this rectangle is A into P by 2 minus A. Now we know that AM is greater or equal to GM. Now we take two numbers A and P by 2 minus A. Therefore A plus P by 2 minus A divided by 2 should be greater or equal to under root of A into P by 2 minus A. This is AM greater or equal to GM. Here we see that A and A gets cancelled. This becomes P by 4 greater or equal to under root of A into P by 2 minus A. And when we square both sides, as these two terms are positive, we get P square by 16 greater or equal to A into P by 2 minus A. Thus we get the inequality as P square by 16 greater or equal to A into P by 2 minus A. Now this is the area of this rectangle. So we see that the maximum value of A into P by 2 minus A could be equal to P square by 16, as P square by 16 is greater or equal to this quantity, and so the maximum value of this quantity could be equal to this quantity. Thus we can say that the maximum value of A into P by 2 minus A is equal to P square by 16. We get the area as equal to P square by 16. Now this is possible only when A is equal to B equal to P by 4. Thus for the area to be maximum, it has to be a square with the side equal to P by 4. Thus we can say that for the area of the rectangle to be maximum, it has got to be a square with a side of length equal to p by 4. Now let's try to solve an IIT problem that appeared in 1984. It says that if a is greater than 0, b is greater than 0 and c is greater than 0, then prove that a plus b plus c into 1 by a plus 1 by b plus 1 by c is greater or equal to 9. So in this problem we have been given that a, b, c are three positive numbers and we have to prove that a plus b plus c into 1 by a plus 1 by b plus 1 by c is greater or equal to 9. So let's look at the solution of this problem. Let us say that the three numbers are a, b and c. Now am is always greater or equal to gm. Therefore we can write a plus b plus c divided by 3 greater or equal to cube root of abc. And let us say that this is equation number 1. So from am greater or equal to gm, we get this inequality, that is a plus b plus c divided by 3 greater or equal to abc to the power of 1 by 3. Now if we take the three numbers to be 1 by a, 1 by b and 1 by c, then again am should be greater or equal to gm. Thus we get 1 by a plus 1 by b plus 1 by c whole divided by 3 is greater or equal to 1 by abc to the power of 1 by 3. And let us say that this is inequality number 2. So this is the first inequality and this is the second one. If we multiply 1 and 2, what do we get? We get a plus b plus c into 1 by a plus 1 by b plus 1 by c whole divided by 9 is greater or equal to abc to the power of 1 by 3 into 1 by abc to the power of 1 by 3. Now this and this gets cancelled and we can take 9 to this side. Thus what we get? A plus b plus c into 1 by a plus 1 by b plus 1 by c is greater or equal to 9. And thus we have proved the result that if a, b, c are three positive numbers, then a plus b plus c into 1 by a plus 1 by b plus 1 by c is always greater or equal to 9. Now with this we come to the last part of our chapter, which is method of differences. But what is this? Let us say that we have a sequence in which the terms are a1, a2, a3 and so on up to an minus 1 and an. Let's look at the difference between the successive terms, and this would be a2 minus a1, a3 minus a2, a4 minus a3 and so on up to an minus 1. Now if these differences are either an AP or a GP, then we use the method of differences. So the condition to use this method is that the difference between the successive terms must either be in AP or it must either be in a GP. But still, even if it's either an AP or a GP, how to solve that? What exactly is the method of differences? Let's try to understand this through an example. Find the sum of the first n terms of the series 2, 3, 5, 8, 12 and 17. So in this problem we have to find the sum of the first n terms of the series, and the series is 2, 3, 5, 8, 12, 17. Now this series is neither an AP, neither a GP, neither a HP, neither AGP. So what kind of a series is this? Let's try to see that. The terms are 2, 3, 5, 8, 12, 17 and so on. Now if you look at the difference between the successive terms, then this difference is equal to 1, this difference is equal to 2, this difference is equal to 3, this difference is 4 and this difference is 5. So we see that the differences are in AP. It satisfies the criteria, that is the difference between the successive terms is in AP. Now what we do is we write S equal to 2 plus 3 plus 5 plus 8 plus 12 and so on up to Tn minus 1 plus Tn. Let us say that this is equation number 1. Again we write S equal to, we begin from this term 2 plus 3 plus 5 plus 8 plus 12 and so on up to Tn minus 1 plus Tn, such that 2 coincides with 3, 3 coincides with 5, 5 coincides with 8 and so on that Tn minus 1 would coincide with Tn of the first equation. And what we do next is we subtract both these equations. We subtract 2 from 1 and thus what we get is 0 equal to, this term remains the same 2, this becomes 1, this becomes 2, this becomes 3, this becomes 4 and so on up to n minus 1 terms minus Tn. This term becomes minus Tn. Now if we take Tn to this side of the equation, what we get is Tn equal to 2 plus, now this one is nothing but sum of n minus 1 natural numbers and this would be equal to n into n minus 1 by 2. Thus Tn or the nth term of this sequence is equal to 2 plus n into n minus 1 by 2. But now we have to find the sum of all the n terms. So the nth term of this series is nothing but equal to 2 plus n into n minus 1 by 2, or this could be written as nth term equal to 2 plus n square by 2 minus n by 2. Now we have to find the sum of all these n terms. So what we're gonna do? We're gonna find the value of summation of Tn, that is the sum of all these n terms. So Sn is equal to summation of Tn, and this would be equal to summation of 2 plus 1 by 2 summation of n square minus 1 by 2 into summation of n. Now we know the value is summation of 2, which is equal to 2n. Summation of n square is n into n plus 1 into 2n plus 1 divided by 6, and the summation of n is n into n plus 1 divided by 2. Thus Sn would be equal to 2n plus 1 by 2 into n plus 1 into 2n plus 1 divided by 6 minus 1 by 2 into n plus 1 whole divided by 2. This further becomes Sn equal to 2n plus 1 by 12 into n plus 1 into 2n plus 1 minus 3. We have taken n and n plus 1 common from both these terms. This further becomes 2n plus 1 by 12 into n plus 1 into 2 times n minus 1. Now n plus 1 and n minus 1 becomes n square minus 1. This 2 gets cancelled with 1 by 12, and so Sn would be equal to 2n plus n into n square minus 1 whole divided by 6. This further becomes Sn equal to n cube plus 11n whole divided by 6. Thus the value of sum of first n terms of this series is equal to Sn, and which is equal to n cube plus 11n whole divided by 6. So this is the way we solve such kind of problems in which the difference between the successive terms is in AP. Now let's take one more example. Find the sum of first n terms of the series. Series is 3, 7, 15, 31, 63 and so on. Let's again try to find out the sum of first n terms of the series. So the terms are 3, 7, 15, 31, 63 and so on. Now once again we are going to find out the difference between the successive terms. For this case it's equal to 4. In this case it is equal to 8. This case it's equal to 16. This case it's equal to 32. Now what's so special about these differences? We can clearly see that these differences are in GP. 4 into 2 is equal to 8, 8 into 2 is equal to 16, 16 into 2 is equal to 32. Thus the common ratio for these differences is equal to 2. And so this is a GP. Now once again what we are going to do? We are going to write S equal to 3 plus 7 plus 15 plus 31 plus 63 and so on up to T of n minus 1 plus Tn, and let us say that this is equation number 1. We are going to write this equation once again such that 3 coincides with 7, 7 coincides with 15, 15 coincides with 31 and so on till Tn minus 1 coincides with Tn. Now we are going to subtract both these equations to get 0 in the LHS equal to, this remains 3, this becomes 4, this becomes 8, this becomes 16, this becomes 32 and so on up to n minus 1 terms, and this becomes minus Tn. Now 4, 8, 16, 32 up to n minus 1 terms are in GP, and we also know the formula for finding the sum of n terms of a GP. Therefore we are going to use that formula to find the sum of all these terms, and so Tn would be equal to 3 plus 4 times 2 to the power of n minus 1 divided by 2 minus 1. This is because the formula is a into r to the power of n minus 1 divided by r minus 1. Thus Tn is equal to 3 plus 4 into 2 to the power of n minus 1 divided by 2 minus 1. This further becomes Tn equal to 4 into 2 to the power of n minus 1 minus 1. Now Sn would be summation of 4 into 2 to the power of n minus 1 minus summation of 1. This would be Sn equal to 4 into summation of 2 to the power of n minus 1 minus the summation of 1. Now Sn would be equal to 4 into 1 plus 2 square and so on up to 2 to the power of n minus 1 minus n. This is a GP such that the common ratio is equal to 2 and the number of terms is equal to n. Therefore this would be equal to 4 into 2 to the power of n minus 1 divided by 2 minus 1, and this is minus n. This further becomes 4 into 2 to the power of n minus 4 minus n. Thus we get the value of Sn equal to 2 to the power of n plus 2. Why? Because we can write 4 as equal to 2 square. So 2 square into 2 to the power of n is equal to 2 to the power of n plus 2. This is minus n and this is minus 4. As the sum of the first n terms of the series 3, 7, 15, 31, 63 and so on is equal to Sn, which is equal to 2 to the power of n plus 2 minus n minus 4. And so with this we come to the end of our chapter on progressions. In this chapter we have studied about the arithmetic progressions, geometric progressions, harmonic progressions, mathematico-geometric progressions, some of the very important formulas regarding of n natural numbers, some of the squares of n natural numbers, and some of the cubes of n natural numbers. Along with that, we have studied about the arithmetic mean, geometric mean, harmonic mean, what is the relation between AM, GM and HM, and what is the inequality that relates AM, GM and HM. Also, we have studied about the method of differences. I really hope that you have understood all the concepts involved in this chapter. Thank you.